In our previous video, we showed our system architecture one, in which we took the original pump on the excavator and we swapped with our digital displacement tandem unit. Thanks to the increased efficiency of the pump and a dedicated system controller that improved the engine utilization, we managed to reduce the fuel consumption and at the same time increase the productivity of the excavator. However, this system has some inherited limitation due to the system architecture. And in our SA2 architecture that we will show today, we are going to discuss how, by introducing simple system modification and a valve block, we managed to separate the pressure level of the excavator and reduce the valve losses. But now let me talk about the excavator system. The vast majority of crawled excavators are equipped with dual circuit system and equipped with also tandem pumps. Certain functions, for example, the boom and the arm actuator, can request up to 2 entire pumps of flow. In order to be able to send the flow from both pumps to a single actuator, in the valve block we have primary and secondary spool that for high joystick commands, they open simultaneously and they merge the flow from both pumps to a single function. However, during multi-function operation, the actuators, they are generally at different pressure levels. So in order to meet the flow requirement and the desired motion, we need to introduce valve throttling. This would result in significant losses in the system, decreasing its efficiency. So here we are trying to tackle this problem by utilizing our SA2 architecture, in which we separate the two pressure levels and we allocate the physical displacement of the pump dynamically with what we call elastic pump. The elastic pump is a system comprising two digital displacement pumps in tandem configuration and a valve block. So the idea behind elastic pump is that the valve block has two separate outlets and we can allocate the physical capacity of both pumps to a single outlet in a dynamic fashion, so varying between 0 and 192 cc per revolution. This is possible thanks to the fact that each cylinder in a digital displacement pump is controlled individually using electronic valves. By grouping 3 cylinders together that we call pumplet, we can obtain effectively separate variable displacement pumps, and a single digital displacement unit can have up to 4 outlets, and 8 outlets are available in a tandem configuration. Inside the ganging manifold for a single pumped input, there are 2 electronically controlled single blocking poppet valves, which can allow the flow to enter either service 1 or 2. A total of 16 blocking valves are powered using a Danfoss +1, and the whole system is controlled using a system controller. After the analysis of the data from a number of duty cycles, we calculated an expected fuel savings of over 30% for the SA2 architecture compared to the baseline machine. This fuel savings was achieved while roughly matching the productivity of the machine in terms of work done by the actuators. Of course, this fuel saving could be traded off in order to boost productivity by increasing the engine speed if that is a customer priority. The SA2 design targets system losses, and we can see how effective it has been by focusing on the grading cycle, where system losses were reduced from 31 kW to just 8 kW. This system is very successful at transferring more useful energy directly to the rams instead of being wasted as seen in the valve block.
Okay, so the machine you just saw on the excavator was really the first prototype of this system architecture number 2. Together with Integrated Cartridge Solution, another business unit in Danfoss, we worked on developing a production solution of this system. Here behind me you see a tandem pump with 2 integrated blocks. Those blocks have the new design of dynamic ganging valves, so based on a spool type valve and 2 check valves. This allowed us to really remove the safety pressure relief valve and reduce the number of valves used in this machine by at least 40%. We are now only requiring 8 outlets, 8 channels to control this block using a +1 controller, for example. This cost-optimized solution allows us to demonstrate this 30% energy saving on an internal combustion engine excavator. This is a very strong value proposition for our customer. And the same apply to electrified machines. Indeed, if you save 30% of the energy of a machine, you can reduce the size of battery or extend the range of this application. Today we're working with several OEMs to bring this technology to the market. They're very excited already. In the future, we have another improvement potential with this system architecture 3, where we can recover the energy of some actuators, and we'll demonstrate that in future videos.